Bismillahirrahmanirrahim. So today we'll be talking about the Schotten-Baumann reaction. So let's begin. The Schotten-Baumann reaction. Now this is the person who is behind this reaction. So what is this? Is the principle. It is basically the acylation of alcohol or amine, whether it is aliphatic alcohol, aromatic alcohol, aliphatic amine or aromatic amine, by the action of acid chloride in aqueous alkaline solution. So you take an alcohol, for example, this is your phenol and this is your amine, that is your aniline. So you react both of them with the acyl chloride, acid chloride. Okay? So if you introduce this group, introducing this group instead of this hydrogen, likely introducing the same group in here by replacing this hydrogen. Now this is basically the Schotten-Baumann reaction. Now what is important here is that it works for those compounds, those phenols where you have this hydrogen, and those amines where you have the hydrogen atom present. For example, you have primary, secondary. But in case of tertiary amines where we don't have the hydrogen atom, so it doesn't work there. So that means those compounds which work with this Schotten-Baumann reaction, they must contain active hydrogen. Fine. So let's look at the mechanism in shortcut. I'm just showing here the mechanism of phenol. The same mechanism works with the amines. Now this is your phenol. We know oxygen is highly electronegative. So this OH bond, this is more towards oxygen. That means phenol is acidic, and we know it is acidic in the lab. And now if you treat with this in presence of base, so base will abstract a proton here. So it forms phenoxide ion. So this is called phenoxide. Now that phenoxide ion attacks on the acid chloride which you use. So what happens? We know there's a CO bond. Oxygen is more electronegative. This pi bond, under the influence of this attack, this phenoxide attack, it moves towards oxygen. So you have this formed. And then in the next step, this Cl negative leaves because chlorine is highly electronegative. And then it creates a positive center here, and then negative charge comes here. So you get, this is your product, phenyl benzoate. So you have basically introduced this group here, this group, RCO. So this is what I said, the acylation. So I introduced RCO group here, RCO. So this is the group you have basically introduced here. So you can see I have introduced this group here. So this is all. You can use the same purpose. You can use the same mechanism for the amine. So this is all what I have. And then you can use this node for the exam purpose, basic node. And the link is in the description. You can download it. If you have any questions, you're free to ask. Thank you.